Chapter 3, Momentum and Impulse. Here are the learning outcomes for this chapter, and you are given 3 selected formulas start from 7 until 9. 3.1, Momentum and Impulse. In this subtopic, there are 3 learning outcomes that you need to cover. The first is define momentum and impulse. B, solve the problem related to impulse and impulse momentum theorem. And C, use FT graph to determine impulse. Momentum P is defined as the product of mass m and velocity v. Or mathematically, to calculate the momentum P, you can use the formula mv, where m stands for mass of object and v is referred to velocity of object. Any object that has mass m and moving with velocity v has a momentum P. Momentum is a vector quantity whose direction of this momentum is in the same direction as velocity v. So you can refer to this diagram. It shows that momentum P is in the same direction as velocity v. The SI unit for momentum is Newton second or kilogram meter per second. As you seen on the screen, there are 2 objects that have a larger momentum. For the first object, momentum P depends on mass m. While for the second object, momentum P depends on velocity v. The more momentum of object has, the harder it is to stop. Or in other words, more force needed to stop it. So based on these 2 diagrams, it shows that both objects are hard to stop because both objects have larger momentum. Since the momentum is a vector quantity, so it can be resolved into x and y component. So when we resolve to x component, you will get px is equal to p cos theta. While for y component, so you will get py is equal to p sin theta. To calculate the magnitude of vector p, we can use the Pythagoras theorem, which is p is equal to the square root of px squared plus py squared. And to get the direction of this momentum p, so you can use the trigonometry, which is theta is equal to arctangent py over px. Momentum is the vector which is equal to the product of mass and velocity. But how momentum related to impulse? When a force acts on an object for a short amount of time, impulse is the measure how much the force changes the momentum of an object. What is impulse J? Impulse J is defined as the product of force and time interval delta t, also known as time impact. Or mathematically, to calculate the impulse J, you can use the formula J is equal to F delta t. So F here represents the force, or specifically known as impulsive force. And delta t represents time interval, also known as time impact. And to calculate delta t, you can use t final minus with t initial. The SI unit for impulse is Newton second or kilogram meter per second, the same unit as impulse, the same unit as momentum P. So impulse is a vector quantity whose direction of this impulse J is actually in the same direction as constant force F. Force of this type, which exists only over a short time during the impact or collision, known as impulsive force. And if you are given an FT graph To determine the impulse J is by calculate the area under FT graph. And this area under FT graph also represent the change in momentum. Impulse momentum theorem. So impulse momentum theorem states that impulse J is equal to change of momentum. According to the Newton's second law, net force is directly proportional to the rate of change of momentum. Or mathematically, F is equal to delta P over delta T. F delta T is equal to delta P. Since impulse is equal to F delta T, so impulse momentum theorem states that an impulse change a particle's momentum. So we can use the formula for impulse momentum theorem as J is equal to delta P, where delta P stands for P final minus with P initial, or MV minus with MU. So by referring to this animation, when a bat hits a ball, an average force F is applied to the ball by the bat, cause impulse to occur. As a result, the ball's velocity changes from initial value of U to the final value of V. So we can state that impulse J is actually equal to change in momentum delta P. Or we can also write that equation as F delta T is equal to P final minus P initial, or MV minus MU is referred to J. When you're using this equation, don't forget to consider the sign convention, especially for V and also for U, because V and U are a vector quantity. So you can use the standard sign convention, which is if object is travel to the right, U and V is positive. But if object is travel to the left, the value of U and V is negative. For upward motion, U and V is positive, and for downward motion, U and V is negative. Question 1. The graph shows the force acting on a tennis ball of mass 60 grams during a return shot. What is the impulse on the ball? So to calculate the impulse on the ball is by calculate the area under FT graph. And by looking to this shaded area, so the area under the graph is referred to area of the triangle. So your J is equal to 1 over 2 times 0.03 times with 200. And finally, you will get the value of impulse in unit Newton second. For B, if the ball reaches the player with velocity of 22 meter per second, so this 22 meter per second represent the value of U, which is moving to the left. So our U is actually equal to negative 22 meter per second. So what is the velocity of the return shot? To the right. So your required is to find the final velocity V. So for A, impulse J is actually equal to area under FT graph. So don't forget to write the concept first for question A, because this one you will get 1 mark for concept. And then substitute the value, which is 1 over 2 times 0.03 times with 200. And finally, the value of J, impulse J on the ball is 3 Newton second. And for B, by taking the motion to the right as a positive value, so to solve the problems, you're using the impulse momentum theorem, which is J is equal to delta P, also equal to P final minus with P initial, or you can write it as MV minus MU, or also equal to M bracket V minus U. Substitute the value of impulse that we already calculate in A, which is equal to 3 Newton second. Substitute the value of mass of the ball, which is 0.06 kilogram, you are given 60 gram. So don't forget to convert this mass into SI unit first, okay, which is equal to 0.06. The value of initial velocity of the ball is negative 22 meter per second because the ball initially traveled to the left. And finally, you will get the value of final velocity of the ball after return shot is 28 meter per second, which is directed to the right. Question 2. A 0.2 kilogram tennis ball struck the wall horizontally with a speed of 100 meter per second and it bounced off with a speed of 70 meter per second in opposite direction. So we are given the value of mass of the tennis ball, which is 0.2 kilogram. The initial speed of the tennis ball is 100 meter per second. This one is our U. And it bounced off with a speed of 70 meter per second in opposite direction. It means that your final velocity of the tennis ball is negative 70 meter per second. So A, calculate the magnitude of impulse delivered to the ball by the wall. So your required is to find J. The second is, if the ball is in contact with the wall for 10 milliseconds, so determine the magnitude of average force exerted by the wall on the ball. So your required for the second question is to find average force. So for A, before we solve the problems for both A and B, we picture the situation by drawing a diagram first. So the initial velocity of the tennis ball that moving to the wall is 100 meter per second, a positive value. And after it hits the wall, it bounces off with a speed of 70 meter per second in opposite direction. So this one, your V final is negative 70 meter per second. So to solve the problems for A, we can use the impulse momentum theorem, which is J is equal to delta P, which is equal to mv minus U. So substitute the value of M. Mass of the tennis ball is 0.2 kilogram. The final velocity of the tennis ball is negative 70. The initial velocity of the tennis ball is 100 meter per second. And finally, you will get the impulse delivered to the ball by the wall is negative 34 Newton second. So this negative value indicates that the direction of the impulse delivered to the ball by the wall is to the left. So this is the direction of J. Since your required is to find the magnitude of impulse only, hence your final answer for this J is equal to positive 34 Newton second. And for B, to calculate the average force exerted by the wall on the ball, so you can use the formula J is equal to F delta T. The value of J is already calculated in A, which is equal to 34. F is our required, and your delta T given to you is 10 millisecond. So we need to convert to SI unit first, which is equal to 10 times 10 power of negative 3 second. So substitute the value of delta T, 10 times with 10 power of negative 3. And finally, you will get the average force exerted by the wall on the ball is equal to 3,400 Newton. So this one is represent the magnitude of average force that exerted by the wall on the ball.